This is Houston. Say again, please.
Houston, we've had a problem. We've had a main beam bus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
Okay, good. I think you're going to have a lot of fun tonight. Just let's.
Hi, Fred.
So,
Let's wait a few minutes more. So, Fred, how's it going?
good. Very good.
Can you hear me
Let
well?
me come here.
Where is the dog?
And Tito's ready to go.
It is.
He's all ready today. He's good. Yep. Give me a few minutes.
Fantastic.
Here, you stay here.
Guys, please stay on mute.
All right.
Okay, so while we are still waiting, a few other guys, we are 54 people at the call at the moment, waiting a couple of minutes more. So, Fred, how is the weather in Houston?
The weather is pretty typical this time of year. It's going to be, and I think in high 80s Fahrenheit. No showers today. We have been having a lot of rain, like thunderstorms, showers, that kind of thing.
Okay.
But we pretty soon in June, and from there till probably late September, Houston normally will be 90 to 95 degrees Fahrenheit every day. That's our normal. Yes, very hot and very humid because we're not that far from the Gulf of Mexico. And but that's good right now for this virus because the virus does not like heat. So in a way, that's, and I guess you got to look at it the good side.
Okay, great. No, that's good. That's good. So I already started recording the call because we want to keep this event in our minds, but also we want to show it to our friends, and maybe tomorrow I'm going to translate for the guys that don't fully understand 100% American and my American English. While we are still waiting a few more guys to join us, let's welcome everybody to the video call. This video call is to celebrate a series of Apollo 50th anniversary events. We started with a couple of live events last year when we had our dear friend Alfred Worden in Milan in September, October. We still are missing a lot, Alfred, and we love him. And then we also had Charlie Duke in November, and between the two, we had Don Iles coming over from Boston. And Fred, I think you know Don because he was part of the instrumentational labs, and he was the guy who wrote the software for the landing routine of the Apollo guidance computer. I don't know if Don is already online. Maybe he will join us. He promised he's going to join us today from Boston. And also we have on the call a lady, Patrizia Carabeo. I don't know if Patrizia is already connected. She is one of our...
Of course, I am connected.
Hey, ciao Patrizia, welcome. Here you are.
You can also see me.
Yeah.
Ciao.
Hi.
And Patrizia has been the managing director of the Italian Institute of Astrophysics. And she is also writing a lot of books about astrophysics,
Okay.
about the moon, and we enjoyed Patrizia giving us some lessons about Apollo missions as well.
Right. One more thing on Draper Labs, not recognized as much. When I flew the Space Shuttle Enterprise and the approach and landing tests, we contracted Draper to develop a backup control system that was totally different and independent from the primary that was software, at least, was by IBM, and that was a less capable system, but we felt a gain margin for stability. So Draper did the backup control system for Enterprise in a single computer, the fifth computer.
Okay. So, okay, let's. Hopefully the internet connection will be good. We also had the pleasure to have Mr. Walter Cugno, is Vice President of Thales Alenia Space, who is one of the biggest companies in the world building spacecraft, and also Walter is our dear friend. Is Walter online?
Yes, I'm online. Thank you, Dario. It's a great honor to meet you, Fred. Really great honor.
Okay.
All right. Yeah, I can see you very clear. You're good.
Yeah, I don't have the same weather that you have in Houston, but I am living in the mountain.
Okay.
Not far from Torino.
Okay. A little cooler.
Yeah.
Great. Okay. We also have Lucas Viglietti from Swiss Apollo. Maybe you remember Lucas. Right. I don't know if he's already joined us. Lucas? Maybe he will join us. Or maybe he's on mute. And then Paolo Attivissimo, that Fred, you met with us when we meet in front of the NASA Space Center a couple of years ago at the Starbucks.
Oh, yeah. Uh-huh.
Nice to see you again.
Okay, so let's. This event has been created between ASIMOF, our association, and BIS, and I have the pleasure to have here the president of BIS Italy, Fabrizio Bernardini. Fabrizio.
Thank you, Dario. I'm not the president. I'm just a branch responsible, of course. The president of BIS is Jerry Webb. Hello, Fred. Nice to meet you. The BIS, of course, is the British Interplanetary Society that I guess you understand by fame. And I would like maybe Mark Hemsel, which has been president and vice president of the BIS. And he's also a council member like me, to express maybe one word of thanks.
I like the instrument panel behind you.
Oh, yeah, well, if you want, yeah, that's one of the activities we do. You should know that. And one of the activities we do is that we build simulators. So we have, this is the close to real size, not really, panel for the lunar module. We also have the CSM. Al Warden use our CSM a lot.
Right. Yeah.
But lunar, it's fun because there are the real switches. So, and we only do the flight control system part. So you can fly the landing, you can do, of course, there are the computer for some other instrumentation. And but it's cool because also it used the original Apollo computer code. So basically we have an emulation of the real software running. So the real software is a fly-by-wire system, takes control of our simulator, and guess what? It works. It's incredible.
Yeah. It'll be a lot easier for you to replicate the instrument panel on Dragon because it's all just
Indeed,
glass.
yes, indeed. Since we also built a one-to-one scale simulator of the Soyuz for the approach and docking. Guess
Right.
what? It is just a matter of changing the moment of inertia, the thruster, and just the panel, and that's it. It's just a software thing. It becomes.
Fabrizio, you can mention also the replica of the AGC we did together. Here it is.
Right.
Yeah, we also, since we are very keen about the Apollo guidance computer, and we know it rather well, we also built the replicas, just a metal replica just to show the real size of the Apollo guidance computer. So we have emulation also of the disk key, and it's interesting. And I think your mission did a lot of strange stuff with the computers, also with the AGS. It's probably the mission that we use the AGS more than any other mission.
Yeah, that we had so many switches because we didn't have much computing power.
Yeah, indeed.
We had to do a lot of things manually.
Mm-hmm. Okay, if you don't mind, I would kindly ask Mark Hempsel. Mark, are you there?
Yeah, I'm here. Just trying to make the video work. Hi, Fred. This is the English bit of the British Interplanetary Society saying hi. We'd just like to say thank you to ASIMOF for letting us join in this event, and it's part of a continuing set of activities we're doing together. And this one's going to be a very memorable one. So,
Right.
Hi from Britain.
All right.
Great. Okay, and then we also had Paolo D'Angelo. You met him at a restaurant in Houston a couple of years ago.
Landry's restaurant. Yes.
Paolo? No, maybe he's busy because of the launch.
There's another Paolo in Houston in that same year with Paolo D'Angelo and another guy. Maybe you remember Luigi Pizzimenti. Hello, Mr. FRED HAISE. This is Paolo Mignusi from Viareggio, Tuscany.
Yes, but we cannot see you, Paolo. We can only see your name.
I'm sorry. I'm trying to switch the device because I'm using my mobile phone and switching on the PC.
Okay.
Give me some minutes, please. Thank you.
Okay, after all this presentation, let me start with a few sentences about our special guest tonight. FRED HAISE was born in 1933 in Biloxi, Mississippi, after a military flying career, in which he had flown for the Navy, the Marine Corps, and the Air Force. He became a research pilot at the NASA Lewis Flight Propulsion Laboratories in Cleveland, Ohio, and he graduated from the Aerospace Research Pilot School as one of the great Chuck Yeager's students. After that, he applied to be an astronaut, and he was rated #1 in the 1966 selection. 19 astronauts were selected there. Combining outstanding technical ability with an easygoing, genial nature, Fredo was assigned as a backup crew for Apollo 8, Apollo 11, and then as a backup commander of Apollo 16 mission, and he flew as a lunar module pilot on Apollo 13. He was also a landing capcom for Apollo 14 mission. He was also assigned to command of Apollo 19 mission, but that was canceled by NASA in September 1970. He flew as a commander for 3 test approach and landing flights for the Space Shuttle Enterprise, the first to land the Space Shuttle on the ground, and the first real commander of an Enterprise Star Trek starship. Ladies and gentlemen, Mr. FRED HAISE. So,
well, it's just barely afternoon here in Houston, so y'all must be in what, about 7 hours difference? So you almost be about 7 at night there.
Yes, it's a great pleasure. So let me start with just one question. We used to say in Italy to break the ice. So I want to break the ice, asking to you why your nickname Freddo, which is a cold or Iceman in Italy.
I'm not sure who gave me that name. There was a tendency to have, I call it a nickname, in the program. Now, traditionally today, pilots, particularly in the Navy, all have some kind of name for them. That wasn't a tradition when I was in the military, but anyway, in the astronaut corps, somebody just decided rather than Fred, I should be Freddo, and say probably a hand down from Gordon Bulletin. Gordo, as he was named, Gordo. He had already been named that, in fact. And of course, behind that, one of the original 7 was Gordon, and named Gordo. So I guess that sort of got handed down, and I'm not sure who gave me that handle.
Okay, great. So let's move to the first real question. We work a lot hard to put down, we hope, some interesting question for you. And the first is our friend Morando from ASIMOF. Morando.
Buonasera a tutti. Good evening, Fred, and thanks so much for your presence here with us. My question is quite simple, I hope, because you have been part of NASA since 1959, and you followed the whole race to the moon. Going back to that time, when did you realize that US was ahead of Russia? And which mission, in your opinion, marked that moment?
I'm sorry, when did I realize what? I'm sorry?
When did you realize that America was ahead of the Russian in the race to the moon?
I'll have to say I was pretty ignorant, as was most of us in the program. We really didn't, and surprisingly, I didn't at least pay any attention to what the Russians were doing. We had a goal, and we were working very hard, mostly 6-7 days a week. Sometimes in some of the testing I was doing at Grumman, I was in test 23 hours straight. Another radar test, 27 hours I was in the vehicle, except to go to the bathroom for a short break. So we were very intent on just getting the job done, what we were trying to get done. And I frankly had no idea what was going on in Russia. And that, to me, it had nothing to do with my drive. I didn't think of it as beating the Russians. I was just involved in a great adventure. And we're going to head to get somebody to land on the moon. And that was kind of my attitude at the time.
So, thank you very much. Thank you very much, Fred.
Thank you. Next one is Carlo. Carlo from Rome.
Hi, Fred. I'm Carlo from Rome, a member of the BIS.
How you do? Hi.
And I want to ask, at the time of the Apollo program, where did you think we would be in 2020 regarding human spaceflight?
At the end of the Apollo program, you said?
At the time of the Apollo program.
What did I think of what? I'm sorry?
Where did you think we would be in 2020 regarding human spaceflight?
I'm sorry, I couldn't understand that question.
So let me rephrase. Back to Apollo time, which was your thought about space flight in 50 years from there?
My thought about space, well, frankly, I thought we had a lot of momentum at the time of Apollo. And of course, I didn't know anywhere near the technical knowledge we have today, but I thought we'd press on and move on to Mars. I really thought probably early missions would be much like Apollo. just a short visit to get some samples and come home. Of course, at the time I wasn't that smart about the other threats of doing that. The time domain and radiation and a lot of those things. But I just knew and felt confident we could do it. And we had a lot of momentum and a lot of people assembled to carry on. And so I just thought the space program would just keep moving right on out. Naively, I should say.
Naively, yes. Thank you. So, and then we have another BIS and ASIMOF member, Mr. Paolo D'Angelo from Roma.
I think it's on the phone with.
How you do,
Paolo? Are you there?
So you got a dragon behind you there.
Okay. No,
thanks.
Davide. Let's move to Davide.
Okay.
Please, Davide.
Okay. Okay. Let's do this to Paolo.
Okay.
Paolo, go on.
Sorry. I'm Paolo D'Angelo. I met you, Fred, 4 years ago in Houston. And I work for the press office in Italian Space Agency. My question is, you and Jim Lovell were backups to Armstrong and Aldrin on Apollo 11. Was the training for the first lunar landing mission more complex or difficult than for Apollo 13? And why are there no photos of you and Lovell during Apollo 11 EVA training?
Okay, I'm not sure I understand either the context of the question. Jim Lovell and Ken Mattingly and I were the backups on 11. And would you say what was the most difficult thing? Well, the only new thing we had to cover in training that had not been done before was the landing itself and the lunar surface activity, which was very minimal on Apollo 11. It was kind of like get out and grab some rocks and put a very few experiments on, deploy a American flag and get back in. So it was a very short EVA, not much training either in EVA training for Apollo 11. And of course the ascent to launch off the moon with the rendezvous with the command module. Obviously rendezvous itself was not new. We'd done rendezvous many times, starting through the Gemini program. So the most difficult mission for me training was Apollo 8. Apollo 8 was much more difficult from the standpoint of a shorter time because we changed missions after wasting about 6 weeks training for the wrong mission when they now told us we're going to the moon. So it caused a revamp of our flight plan, our procedures, a lot of things, mission rules. So all those had to be worked, and some of it tested in the simulator to redline and perfect to get the checklist right. So we probably ended up losing overall a month to 5 weeks of our training, 6 month training cycle on that mission. So it put us in a bind getting ready to go fly that mission.
Okay,
thank you.
Great. Thank you. And then we move to Davide in Roma, still in Roma.
Oh, hi. So I have a question. Given the experience on both programs, what do you think was the biggest difference between the Apollo program and the Space Shuttle program, especially from the point of view of a human-machine interface?
Okay. Well, I'd say the launch is fairly equivalent in the sense of that's the high-risk part of any launch. Mission, rather, is the launch phase with the big rocket, whether it be a Saturn V or it be the one behind you. So that's the risky part. As far as the crew on the launch, the crew is mostly a passenger. That was the case in Apollo. We had some abort capability, including supposedly return to the launch pad. and abort even to once around kind of thing, or landing at alternate fields in Spain and in North Africa, just across the Atlantic. The Apollo capsule, as well as the now the Dragon, have I call it better launch escape capability all the way up than we had with Shuttle. As far as now the flying on orbit and then mainly entry, which was the other dynamic phase, the Shuttle was much more complicated. The control system went through about 4 different modes from the time you started the deorbit till you got down to probably about somewhere below Mach 5, where you sort of now the rudder was activated. The rudder didn't even work till you're to that part of the entry system. And so you're now probably to a normal airplane through that region on to landing. But above that, you used a variety of the rocket attitude thrusters, the body flap, ailerons, and in fact, at one point operating backwards because they created more yaw than at the high angle of attack, they created more yaw than rolling moment. So they actually were used to assist in yaw control rather than roll control. So your control system was somewhat reversed there at the point. So anyway, that's the main the differences. The interfaces, of course, you're talking about crew interface. Of course, we did have the advent of the CRTs, now a pseudo glass cockpit to do a lot of our commanding of different parts of the system with a screen, several screens. In fact, we had 3 screens in Enterprise. And so that was a new advent in terms of the crew interface. But we still, as you saw, had a lot of switches in Shuttle, as well as we had in Apollo, because computers had not gotten that much bigger. The IBM 101 I flew Enterprise with was a hand-me-down computer from the Manned Orbiting Laboratory program that the Air Force had planned to fly but was canceled. And it was about 1 megabyte. So that was the size of the memory in that computer we flew Enterprise, about 1 megabyte of memory. So things had not advanced quite that far with flying machines at that point. Now it got bigger for the orbital birds. We went to a double density machine, and it was bigger for Columbia and the subsequent ships that flew to orbit.
Okay, thanks.
Good. So let's stay on the argument, asking to Tommaso to place the next question. And Tommaso?
Hi, yes, hello. Hi, Fred. How are you? You're looking great. You're looking fantastic.
Thank you.
Okay, I'm calling from Rome. I work for the European Space Agency.
Okay, you hear my watchdog? Yeah, what's this going on? My watchdog. Somebody's coming here. There you go. I'll let him out the door here so he can go attack whoever's at the front door. All right, go ahead.
Hi, so calling from Rome, I work for the European Space Agency, which today just is 45th birthday, so it's founded 45 years ago. Here's my question. I think continues a little bit of what was said before. Between the Apollo and the Shuttle, there was an incredible technological jump. How does this change your view and your training from Apollo to Shuttle?
Well, I think trying to think, the systems were a little more complex in the sense of how many spares we had. We had like what I call fail-ops, fail-safe capability on Shuttle. So probably what increased dramatically, and a part of the software we had was called system management to handle failures, where they would down select, and you, of course, through the keyboard, could down select yourself to isolate the components of the system by keystroking. So there was a big add in that sense. As far as the basic flight array, you fly the airplane, it still had an 8-ball, it had and altitude, airspeed. You know, it had all the conventional things you would have, even in this case, even in an airplane. So the system management probably was the biggest new adjunct to learn. And of course, we had a lot of problems with it early on. In approach and landing test, we had a problem with air data probes. They were on each side. And we found when the 747 ran a long ways up to the north with the sun hitting on one side to the east, it would heat that probe to cause a fault, an alarm in essence, because they got it past the temperature differential of measuring air temperature and things like that. So we found a lot of false alarm problems with that system during approach and landing test. But that was probably the major adjunct we had with flying shuttle versus the capsule. Of course, we were situated differently, more in a airplane type seats, and so the geometry within the cockpit was obviously a lot bigger, including had a downstairs area with later a place to clean up and a bathroom, and most of the storage was downstairs on the lower floor where you went in through the hatch. So it was that was the biggest differences I saw from shuttle to from the capsule.
Thank you very much.
Great. So let's move to Annalisa, because I think Simone would like to ask you something. And Simone is our youngest member. It's 11 years old from BIS.
Good morning.
Hi.
Hi there. Hi.
So his English is so Mom is gonna talk. First of all, we're really honored. It's a big honor for us because you are history for us. You can see here.
Wow. Okay.
So no, Simone, he will be 11 June the 1st. We're about to have a birthday. And since he was 5, he wants to be an astronaut.
All right. Well, happy birthday ahead of time.
Thank you very much. And he just wanted to ask you an advice, considering and if there are many changes in how astronauts must prepare today, reporting to your preparation, and is still so important to be a pilot and to be so prepared to manage the flight today with the new techniques. So just an advice of what he must be focused on the most. Thank you.
All right. Well, first of all, it depends on which mission and which vehicle. Now, on Apollo, obviously, and through Shuttle, the people who primarily operated the vehicle and worried about taking care of things if things went wrong, had sat in the front 2 seats at least, or in the couches in Apollo, did have a piloting background. No, just about all of us were test pilots, either in the military or in my case with NASA for 7 years before I went in the program. But that changed a lot in Shuttle because we did a lot of experiments, worked with that. So it added mission specialists and payload specialists, and their background was more keyed in science and engineering, all various sorts. I mean, astronomy, you name it. We had people with all kinds of background experience, and that has grown more in ISS and the space station, because obviously it's a big, large laboratory in space. It's going around right now as we're talking with people, and the main purpose is to conduct experiments, scientific experiments on humans in space. And again, so the primary skill of most of the people that get involved today and are chosen in the program are scientist types. I call them scientists, medical people, medical doctors. So a variety of talent that way. Now, some pilots have still been brought in, although I think they're a smaller part of a selection today because they're planning on flying, as we're hoping to see a launch today of Dragon, which is a commercial vehicle by SpaceX. And the 2 crewmen on board, obviously, will have had some piloting background. And I'm sure it'll be similar for the Boeing craft when they put crews on it. Initially, till the vehicle's perfected, you'll have pilots to run that. Now, if you go further downstream to Mars, I really don't see much of a role for a pilot. Possibly the launch phase, but on the way to Mars, other than the scientific types that will be there to really do the mission at Mars and support that, geologists and scientists of various sorts, you really need one skill I know you think you need is a good, like a mechanic, a system fixer-upper, because when you go to Mars, that's a long, long ways, and you're far away from the nearest Lowe's or Home Depot. I don't know if you have those in Italy, but you're not going to be able to get things to fix things up. So you're going to have to, you're on your own. So you're going to need that kind of person skill in addition to the scientist, more than a pilot on a very long, long range mission like to Mars. Because I'm sure by then the system will be so good with the computers, the landing would be automated. So possibly for takeover, you might want a pilot there, but if it didn't work right. But other than that, it's, the piloting role is very minimized, and that kind of long range mission we might do someday.
Great, thank you.
Thank you very much.
Great advice. I think we have also other people like Anna from Torino. She wanted to become an astronaut.
Hi. Yes, it's my dream. It's my big dream.
All right. What's your name?
I'm Anna. I'm from Turin. I'm a student.
Okay. All right.
Yeah.
So yes, we have.
So what are you studying?
I'm graduating. So I will start university next October. So I'm just at the beginning. So
okay.
Yeah, your experience is so inspiring for me, I think. Yes.
Okay.
Good. So let's move back to the next question. It's coming from Professor Zatti. So Stefano, would you like to ask the question to our friend, Mr.
Yes,
A?
thanks. Yes, thanks. Can you hear me? I am muted.
Yeah, I can hear you and see you well.
Hi.
With a starry background there.
Yeah, the background is just the view out of my window, because I'm in Rome, but I'm overlooking the city over the hills.
Okay.
So I'm also from ISA, although I recently retired. So I'm also celebrating, like my friend Tommaso, the 45th anniversary of the agency. And my question is related to piloting the shuttle, which is the fascinating phase of the landing, which is basically gliding, which was basically like piloting a glider. So somehow you have already mentioned the importance of piloting, but my specific question is how difficult was it for the pilots to approach, to fly down and landing without any possibility, any margin for any mistake? And in particular, what was the support you got from the navigation computing that you had on board, which I imagine was better than the one that you had on the Apollo?
If you're talking about approach and landing test?
Yeah, approaching and landing the shuttle without any propulsion, just gliding.
Yeah, the shuttle actually was not too bad a glider. It approximated the X-15. Remember the X-15 rocket ship? It was about a 4.5 lift to drag. That's kind of a performance parameter for gliders. And the shuttle was about the same. They were almost identical gliders in their capability, subsonic gliding capability. Of course, sports gliders get up to 40 to 60 L over D. So it's not a super good glider, but adequate. And virtually where we flew ALT and we were released, we were right beside that big Rogers Lake bed. So without any guidance at all, I could look out the window and make it land on that big lake bed. The runway we first landed on for all but one of the flights that landed was on the north-south runway on Rogers Lake, which was 8 miles long. And on that dry lake, you could veer off to the left or right off that sort of painted asphalt strips were put there to resemble a runway. It really was, the lake bed was all, you could use almost all of it.
No.
You could veer off the runway quite a ways left or right and still be okay. So it really wasn't that much of a navigation problem. Now, coming from orbit, it's a little different. You have to have the capability of your inertial system active and had state vector up to date before entry, and then depend on updates from TACAN stations as soon as you can get out of blackout enough to pick up stations to update the state vector so you can more accurately get to that spot that you're assured the capability of a lift to drag or your gliding capability to make the runway. So it's a little bigger problem coming from orbit.
Thank you. That's great.
Thank you, Stefano. So I noticed that Mr. Don joined us. So Don and Denise, are you?
Oh, yeah.
Hey.
Hi there.
Don will be over in a second. How is everybody?
Okay, where are you? Where are you?
In Boston.
Oh, okay.
Live from Boston. There's
Hey
Don.
there.
How you doing? Good to see you.
Okay.
Yeah, no, I think there may have been a disconnect on the time. We thought it was starting at 2:00 Eastern
Well,
time.
yeah, we shifted it because we're thinking of the launch that we hope is going today.
Well, we can cross our fingers.
Yeah. We have that on in the background too.
Okay. All right.
Yeah, we can look over your shoulder and see the television.
All right.
Behind us. And where are you? You're in Texas?
I'm in Houston, Texas.
Okay.
Nice.
About 5 miles north of Johnson Space Center.
Okay. Yeah, no, I enjoyed my short time living in Texas, but that was not in the Apollo era. That was in 1995. I was there for about 7 months trying to help Boeing with the space station.
Oh, yeah.
They weren't all that receptive to my help, unfortunately.
All right. Well, you were past my time. I was on space station from about 86 to 91 with Space Station Freedom.
Right.
Remember,
Exactly.
in fact, I'm writing a book right now and discussing all the travesty and the problems we had with trying to get that gone through. As I reviewed my notes on that period, I'd say, I don't think I could sell this story to Mad Magazine.
Pretty good. Are you going to cover your Apollo years also in your book?
Oh yeah, right. Yeah, it'll be in there.
Okay, excellent.
That was tough times with Space Station Freedom. Budget-wise, horrible. We went through several administrations. We went through 3 NASA administrators.
Yep.
I went through 4 different. I was a contractor then for Grumman, and I reported to 4 different NASA leaders. They kept changing. So it was a traumatic program and hard to keep people because they thought the program was going away, with the budget cycles.
Right.
Yeah.
Well, I was at the lab. I was still at the Draper Lab in Cambridge, trying to help with that all the way back to the Power Tower space station, which I think
right.
was
Yeah, that was early on that Johnson had when they had the program office, and that was the other big problem. They shifted everything to Washington and Reston.
Right.
People didn't want to go to Washington.
Right. Well, those were the days when we were trying to get NASA interested in Timeliner, which was a sequencing program that I invented that we had at the lab. And we finally got some traction, and that is now running on the ISS.
Okay. Well, they got there. I'll have to say, I have to admit, in spite of my trepidation when I left the program, and went back to my the company I'd started, GTSI. I was worried, but sure enough, the Russians joined up, and the thing then got reasonably solid funding to finally get built, and here we have it. It's going around right now.
What are you doing now other than writing your book?
I've been involved with a number of not-for-profits. I actually worked longest, probably now 14 years, with Infinity Science Center, Inc., a not-for-profit where we raised $40 million to build a science museum in Mississippi, nearby Stennis Space Center. And I was involved with 3 of the flight directors from Apollo 13, with Gene Kranz and Jerry Griffin and Glenn Lunny, on a not-for-profit board where we raised money to refurbish the historic mission control at the Johnson Space Center, to get that rebuilt in pristine form. And I've been now a trustee. I got bumped up to board on the Astronaut Memorial Foundation in Florida. So that's kind of the way I mostly contribute. I can be good with fundraising for those kind of things. And be helpful in that way. I do a lot of talking this way, not Zoom, particularly since that's kind of a new advent here with the latest situation. I've done a lot of Skype talks with schools all over the world, really, with all the way to Australia, all over Europe with school children, which is pretty easy to do with Skype over the years, that kind of thing.
Great. So, Fred, are you still painting the Saturn rocket in Mississippi?
I'm sorry, what's that?
Are you still painting? You were painting the rocket at the museum, right? At some point.
I'm not sure painting. We moved the first stage of the last Saturn V that was built at Michoud plant in New Orleans. We moved it to Infinity Science Center. It now sits on the west end of our building. It was the one that would have launched me on Apollo 19, had we flown Apollo 19. And we have a full-scale lunar module there now. Right, that's it. We have a full-scale lunar module there, and it was the trainer that was at Kennedy Space Center in the training building that I trained in a lot. Most of the astronauts did, involved with the lunar missions. So we have that full-scale LEM lunar module parked right adjacent to where the Saturn V first stage is. So yeah, we've got it pretty well equipped now as we originally intended. It's been open now and it's in the 6th year. Well, we're fixing to open June 1st, which is a couple of days. So the museum will reopen June 1st. And we didn't raise our 40 million, we raised 32 million, which enabled us to build a building. And then we had to kind of scrounge a lot of pieces and parts from various NASA centers to fill a space gallery. But we've grown on up now more with a lot of interactive kind of exhibits, which is our intent. We had a Walt Disney designer that helped us with the design for those, which is kind of the modern way for museums, is they have hands-on interactive, which of course a lot of younger people are more used to. When I say younger, from probably 50 years old on down, for me it would be younger.
Yeah.
Anyway.
So, in case you need a full-scale Apollo capsule, we can rent you.
I know. I've seen pictures of it with Luigi hanging out of it. Yes, I've seen pictures of it. That was a great job. Incredible.
Okay, let's see if our friend Walter Cugno from Thales Alenia Space in Italy has a question for you.
You have to unmute. Yes, I am curious about, not really a technical question, Fred, because I read that everything was readable on your mission, in all of Apollo mission, because It's not only because I am in the business, but I am a real passion for space and for all the moon mission which happened in the time where I was a young student. You had the opportunity to land on the moon, and you missed this opportunity. But your mission became a legend, really, in the human space flight. And it's also a study case for most of us to understand how to deal in that kind of situation. And everybody, people are recalling the normal people. I don't think about the people like us, which are real passion for everything. But the normal people recall Apollo mission as a two mission, Apollo 11 and Apollo 13. So how do you feel about this? Thinking that you will be remembering forever because of this outstanding, incredible mission.
Well, I'm obviously happy that Apollo 13, I guess, is sort of backing into becoming a folk tale. I frankly would rather have landed on the moon, personally. But nevertheless, it does stand out, just because of the drama and the criticality of the failure we had to deal with as a obviously a very graphic example that in fact was made into a movie about handling problems and a team working to handle problems. But truthfully, we had that capability and was exhibited not as dramatic on several other missions. Apollo 14, we almost aborted the landing. Where it had we think, a solder ball and the abort switch. They couldn't go into the P-63 landing program, or they would immediately put them in an abort. And I think Draper Labs worked their work around to manually keystroke in, Ed Mitchell keystroked in to, in essence, make the computer not look at the abort switch, so to speak. And that way they could go in a P-63 and go land. Apollo 16 had a similar situation where they had actually separated the limb and were getting ready to land. And when Ken Mattingly tried to do the maneuver to go back to higher altitude, to 60 miles, they had a secondary servo problem on the SPS rocket engine that they had to wrestle with, and actually I think did some tests at Downey, California, and the ADL facility or whatever there, to prove that it would be all right to continue. So we almost aborted Apollo 16. It would not have landed.
Technically, that violated the mission rules, didn't it?
I think Jim McDivitt allowed that to
okay.
proceed, yeah. Yep. But at any rate, that's another case. But I'm saying most problems had some problems. Some of them, again, not as dramatic. But the nature of our training was just that. We had all of our training, thousands of hours in simulators, were based around a group taking advantage of the simulators available in by the simulator. In case of the command module, over 500. There were over 500 what we call credible failures that could be put in to test you. And we, I think, started an actual Gemini program, developed this group called SimSoup. Talented, bright people who knew the vehicle, knew the systems. And their whole livelihood was to think up scripts for each of our simulations with the hope they would make us look bad. Would make us and mission control combined look bad. So they deliberately pick failures to be imported in a certain time in a certain sequence that would give us problems. And so that was your whole training was just that. So failures were not new. I mean, the mission was kind of boring when it went all okay because you didn't have any of these interruptions to deal with.
Thank you.
Great. Thank you very much. So let's move to Alessandro.
Hello, can you hear me?
Yes.
Oh, perfect.
Roma.
I'm Alessandro from Rome. Thank you for being with us, sir. And I have a question for you. And it is, was the Apollo 13 experience a driving factor in any other choice in terms of hardware, system architecture, risk management, or procedures of NASA's subsequent programs. For example, in the Space Shuttle or the International Space Station. And if you and your team were involved somehow, I mean, either the crew or the engineer or the engineers that work with you, if you were involved in similar activities.
I'm sorry, was I or engineers involved how?
What I was trying to say is, what I was trying to ask is if the Apollo 13 experience was in any kind of way a driving factor in the choices of NASA's subsequent programs. And if you and the crew or the engineers were involved in the new selection of system architecture, procedures, risk management.
Are you talking about were we involved in like the fixes that were done after Apollo 13?
Yes.
Or are you talking about the next program like Shuttle or whatever?
You gathered something from that experience, and if you helped in it.
Yeah, they obviously Apollo 13 was treated as it was an accident. So you normally treat it just as today you would if an airliner crashed. You do a complete accident investigation. A board was created. A fellow named Ed Courtwright, who was head of NASA Langley Research Center, was the chairman of the board. Neil Armstrong, I think, was Neil on that board? I think Neil contributed to that board. So there were astronaut contributors, and they looked obviously at all the data. And out of that review, just as FAA would do in the U.S. for CAB rather for an airline accident, we'll have recommendations of what to do differently before you fly again. And certainly that was the case here. They added on a limb descent. They put cryogenic tanks on the opposite side of the vehicle on a service module before Apollo 14 flew. So those kind of modifications were made before Apollo 14 was safe to fly. Now, I'd say that was part of the problem with NASA. Normally, major components like cryogenics, where you have oxygen tank 1 and 2 and hydrogen tank 1 and 2. In a military airplane, you would have had those on opposite sides of the vehicle. It's just normally a mil-spec custom, because if you get hit with any aircraft fire, you don't want it to get all systems at once. Of course, NASA wasn't expecting to be in combat, so they just stuffed everything together in that one bay in the service module, which set us up for that problem of one affecting the other. But anyway, yeah, you normally do just as they did after the Apollo 1 fire, and they did after Challenger, et cetera, after any accident. That's a very thorough review is done to fix things and make things safer before you fly again.
Thank you very much, sir.
Great. So next question is from Luciano, again from Roma.
Yes, thank you. Hi, Fred.
Hi.
Thank you very much for this incredible opportunity for all of us. I'm calling from Rome. I work as satellite system engineer for an Italian space company. My question is, do you think that the changed risk policies about manned space flight after the Apollo program affected the rush for human space exploration so much as to abandon the spirit of acceptance of the inevitable risk that is always present in any human space exploration activity? And so, what policy do you think there should be for the next future human space activities?
What should be for the next human space activity?
Yes, the risk policies.
The risk policy, he said.
The risk? Well,
yes.
You know that there's various ways. They tried to do a statistical analysis in Apollo. To me, what makes you feel better is that you have the right team, the right procedures through manufacturing and testing the vehicle, quality, overlooking things as you're going along. And that's what gives you confidence in the vehicle that it will perform and will meet specification. is the testing to the extent you can do it before, including support equipment, GSE, ground support equipment, whatever, to emulate the actual flight situation, thermal back test, those for the vehicle, those kind of things, and to assure it's ready to go. I mean, that's what gave me confidence in when I flew, and same way with an airplane, that we've worked it and thought about it enough. If we've made modifications, all the what ifs, and have thoroughly tested what we've done in that modification as best we can on the ground before you go flying, when I was a test pilot. So it's similar. That's what to me gives you confidence. But of course, there's always risk. I mean, particularly if you're trying something for the first time, because particularly a spacecraft, unlike an airplane, you can't take it in as small as steps as you approach, like flying a new airplane. You can do taxi tests and go down the runway a few times to higher and higher speeds, and then have a very simplified initial first flights, as we did with Enterprise. But you can't do that with a spacecraft. The first time it comes off the launch pad, it's gone all the way or not. So it's a little higher risk in that sense.
Okay, good.
Thank you very much.
Thank you, Fred. And then we have a member of ASIMOF, Davide, that would like to ask you a question. Davide.
Hi, can you hear me?
Hi there. Hi.
Hi. First of all, thank you very much for this opportunity. And I'm calling from a little city near Milan. And my question is, what do you think about the new space economy and the possibility for private enterprises to make a profit with space? And what role will space agency have in this new scenario?
Okay. The only thing we can compare is what's underway now with NASA and SpaceX and Boeing. I know SpaceX initially complained about NASA's call it oversight to an extent that they felt was maybe not needed, but NASA was funding. Most people don't think of it that way, but the early enterprise on all those was by U.S. government funding to support those enterprises to become a company. Now, SpaceX has done well, not just with NASA. They've obviously flown commercial flights. And I think they're now tied into flying for the Defense Department. So NASA is not their only customer. So to me, they look the best right now suited to growing up to, quote, a company with a space business. I don't know how the Boeing thing will turn out. They've had the one flight which was supposed to go and rendezvous with space, unmanned, which was supposed to rendezvous with the space station. And they had some problems with trajectory on the way up that they could not accomplish that mission. I would argue if they had people on board, they might have been able to pull it off. They had even a simple cue card to follow a profile, and later with the ground work out amended burns to work out the rendezvous. But nevertheless, it did not make it. So I don't know how far they will go. I don't know that they've had any, till they get going, they will have any play into the other, call it other commercial market. And but obviously you would always like two parties enable you to get to space. We saw that in the Defense Department, obviously left Shuttle for that reason. They got very worried of having all their eggs in one basket with Space Shuttle. And of course, when we lost Challenger, it took well over a year to get back in business. So you'd like to have two ways of getting to space if you like to support like ISS, space station. Right now, hopefully this launch is successful today, and we will now once again have two choices, Russian Soyuz and the Dragon as a way of getting people up and down.
Great. I'm sure.
Okay. Thank you very much.
I think your statement could open a great conversation, but we still have 2 more questions for you, Fred. So, and the next one is coming from one of the engineer who worked at the Apollo, who unfortunately could not be with us today, David Baker, but we have Steve from BIS UK that is going to ask you the question on behalf of David. Steve?
Hi, good afternoon, Mr. Haise.
Hi there. Hi.
Can you hear me okay? Yes?
I can hear you fine.
Excellent, good. Again, obviously, thank you very, very much indeed for taking the time to be with us all today. And I'll read you this question as best as possible. David, he's the current editor of our monthly magazine, Spaceflight, for the British Interplanetary Society. And as Dario said, he couldn't be with us today. But he's been wanting to ask you this question apparently for quite some time. Somehow he just didn't get around to it. So I'll do it as best I can. How much did you know about the Block 3 Apollo CSM being developed by North American in the mid-1960s for the month-long I series, as against H and J, lunar photography mission, which most of the available Delta V went into a plane change divided between the Saturn V and the CSM. It formed the basis for the post-Apollo 13 life extension modifications.
All right. No, I'd have to say I knew nothing about that. I mean, vaguely I heard there was a possibility of a follow-on lunar mission for an orbital mission, more to get complete photography coverage of the moon. But that's about it. I mean, more what I would have read in media than actually ever having been involved in that development.
Right. Thank you very much. By the way, you share the same birth year as our British Interplanetary Society in 1933.
Okay. All right.
Thank you very much.
You're
Cheers.
very welcome. Yes, sir.
Great. So, still last question from the list from Fabio, BIS, Roma.
Hello, sir. Can you hear me?
Hi. Yes, I can see you and hear you.
All right. First of all, I would like to express my my complete appreciation for the opportunity to be here to speak to you. It's an incredible honor to me, really. And my question, first of all, I'm Fabio Marturano from Rome, BIS, and I'm an Italian Air Force Weasel, okay? My question is, sir, based on your personal experience, do you agree on new spacecraft controls to completely rely on push buttons rather than more instinctive control sticks or joysticks?
Put the mic a little closer. You lost me on the last part of that.
Okay, I'll try. Can you hear me now?
Okay, go ahead. Try it again.
Okay, sir. Based on your personal experience, do you agree on new spacecraft controls to completely rely on push buttons rather than more instinctive control sticks or joysticks?
For a new spacecraft to rely on what?
On
the touch screens, I think.
Touch screens and push button instead of using joysticks.
Okay, to rely on, I'm sorry, say that again. To rely on what?
Can you hear me like this without my headset?
Okay, try again.
Okay, my question is, based on your personal experience, do you agree on new spacecraft controls to completely rely on push buttons rather than more instinctive control sticks or joysticks?
No, I'm sorry, I don't understand.
Let me translate. Do you think a spacecraft still needs to have a joystick?
Should it have a joystick?
Yes.
And not the touch screens and the new push buttons.
I can't answer that. I hope they've checked that out in a centrifuge. Because I don't know a G-level that will be under a Dragon. Frankly, I don't know what the capsules, and I certainly have that data since Dragon has flown quite a bit on the supply missions. How much G's they are there to go and launch and entry to be able to reach forward and properly keystroke under those conditions.
I don't know how you would
certainly. I'd say certainly for critical functions like an abort. I hope they have something like a handle or something somewhere if they actually the crew does a override abort rather than have to keystroke something to do that or anoint one thing on the panel. But as far as the joystick, it depends on how much takeover and capability you want with the crew to do. I'll go back to the Boeing mission that failed. If the crew had been there with just a card that gave you H dot and airspeed at every minute of the trajectory that you could check against your instrumentation, they could see when things went awry and do a takeover and manually, not as good as you could automatically, but manually follow the similar path and have quite maybe more dispersions when they shut off the engine. But then it would be possible with, again, it has to be ground to help to compute now new maneuvers that would get them back in the right rendezvous sequence. But they could have taken over manually in that case and salvaged the mission. So it depends if you want that capability or not. And certainly in that case, a hand controller, be it a joystick, a hand controller, I'm sure you could probably learn to use a joystick to still do it. Takeover. Now, that's just how far you want to go to let the crew in the act, I guess, as a pilot in the piloting sense. Yeah, but I know if they had just had a P-30 program on board to put in the next maneuver set, you could have salvaged that mission.
Okay, great. So we have a couple of more questions. One from Patrizia. Patrizia?
Okay, yes, here I am. I am in my kitchen since I am preparing dinner. And my question is very simple. Could you tell us how was the relationship between von Braun and the astronauts? How often did you meet him? What kind of discussion were going on between him and his office and the astronauts?
How much dialogue was going on between who?
Between the astronauts and von Braun and the launcher guys.
Okay. Yeah, there really was very little going on. Most of our astronauts were involved, and myself included, in the spacecraft, either the command and service module or the lunar module. Frank Borman, Stu Rusa, and Charlie Duke, I think, did some work with Marshall in looking at the Saturn V design, and they even worked. There was a takeover capability. If the IU failed, there was one switch. You could go to the CMC and the command module and try to fly the Saturn V. The simulation said you probably could get it in orbit, but the inefficiency of that control was that you likely would have used too much fuel in the third stage and probably negated being able to do the next maneuver to go to the moon. With a lot of simulations we did trying to fly the Saturn V. So that was still a capability. That was about the only interface. If you look at the launch, starting with Mercury through all of Shuttle, And same way Soyuz to date. The crew has mostly been just a rider. The last time a launch has been fully manually controlled, the only person still alive, in fact, that's done that is Joe Engle with the X-15. The X-15 was fully manual from the time it dropped off the B-52 all the way through ascent to set that profile going uphill, and fully manually controlled through entry. So that's the last time a human being has been in launch through Mercury, Gemini, and Apollo, and Shuttle. The crew has just been there sitting and monitoring and hoping they didn't have to do an abort. So that's the circumstances for launch, at least. Now, the crew did get more interactive, obviously, in the shuttle through a landing, and of course made the landings at the end of the entry phase in all flights.
Thank you.
Great. And then I saw that we also have Mr. Paolo Ferri, who is head of mission operations at the European Space Station, would like to ask you one question. So, Paolo, please.
I worked all my life in mission control, but mainly for unmanned missions, interplanetary probes and things like that. So my view, especially for the Apollo times, was percentage-wise, how much of the information from the spacecraft was available to mission control and how much was only available to you astronauts in flight, and you had to communicate by voice.
Okay. You're talking as far as the instrumentation and telemetry.
Yeah.
It was a mixed bag. For instance, one of the problems we had on Apollo 13 is the G-shock of the explosion closed some valves that overcame spring tension. The way most gaseous and fluid valves worked was you had a little toggle switch on the panel that you toggle open or closed, and then a spring would hold the valve in that position, open or closed. Well, what happened with the explosion is it took some valves, a number of valves that were open, and the shock of the explosion closed the valves. That was, we could not see that on our panel. We had little bitty square things that were gray if the valve was open and bobber pole if they were closed, but that was only tied to the switch. So only mission control had telemetry to look at the real position of those valves. So a lot of warning lights, we had about 7 warning lights on after the explosion, and a master alarm and a blue computer restart light. A lot of those were false because it was just the valve had closed. So when mission control, through their telemetry, figured that out, they had us retoggle the switch open to reopen those valves, and a lot of those lights went away in some of the systems. So there was a mixed bag where they had telemetry on the ground. They had much more data than we had on board the spacecraft with our normal instruments.
Okay, thank you.
And then Don Iles, do you have a question?
Yes. Fred, we were only in the same room a few times that I recall during Apollo, but one of those times was interesting. I worked with Alan Klump on the lunar landing guidance, and he became very concerned after Apollo 11 with some of the rather peculiar things that could happen if we had some degree of time loss, such as we had 13% of on 11. And he made a very unpolitical call one morning to your commander, to Jim Lovell. And that led to a bit of controversy. And it led to a briefing that took place, not with Alan Klump, but with Russ Larson. And it took place in crew quarters about a month before you launched. I'm wondering if you remember that meeting and if you'd care to comment on it.
Vaguely, I remember. Obviously, I remember Russ very well because he supported me. I led 2 software scrubs in an early shuttle. And Russ helped me greatly with those software scrubs Black Fridays, we call them, that we went through in those days. But no, I don't recall the specifics of that. One point before we leave the manual control thing, for the first lunar landings, I don't care what you do them with, you're going to need a manual capability, because the circumstances are the first time you know what's there, where you're going to really land, is when you pitch over and get a look at the ground. Until they get, if they can land, for a colony, they keep talking about our lunar base, if you eventually get to a concrete pad, something that's sitting there where you know specifically where you're going, then you can go fully automated. But every landing that was made, the crew had to take over and move to avoid boulders, because we do not have that definition of what's sitting there on the surface. Mm. So it don't matter where they choose to land this next time, there's going to have to be a crew there that can really wiggle a little bit near the final approach and to landing to make sure they clear boulders.
That's great. So I think our friend Claudio Maccone, and Claudio is a SETI man, chairman of SETI. You know SETI, Search for Extraterrestrial Intelligence. He would like to ask you a question. So Claudio?
Yes, first of all, thank you very much for giving us this opportunity to ask the question. Really appreciate it. Now, let me just first make a statement about the moon far side, and then I come to the question. The statement is that, as you certainly know, the orbit of the lunar gateway, that is the new space station that is going to orbit around the moon, has been selected in such a way as to minimize the time when there will be no possibility of talking in between the people in the station and the Earth, because the moon is in between. Okay. So this is a good news, of course, because you have less mute time. But let me ask you a question. When you underwent the training before the Apollo 13 flight, did they give you special instruction for doing something or not doing something during this mute time? Thank you.
I'm not sure how to answer that. We had the instructions we had were in our procedures, and basically we followed those unless something didn't go as per plan. And of course, we had abort procedures as well. So most of our what we were going to do was pre-thought, and we trained to do the normal as well as the abnormal on any given mission. As far as the gateway, an interesting question. I wonder if they've really thought about it. It's the orbit it's in, which I guess goes out about 3 days from the moon. How do they handle any time aborts? Because any time they start that landing procedure, anywhere downhill or even after landing in a short while, they may have to abort. And the one advantage we had of the command module was it was nice in a nice fixed stable orbit to get back to.
Yeah.
I don't know if they've thought of that in this orbit they plan that gateway to be sitting in.
Well, you're right, actually. I said that the orbit was selected in order to minimize the time of silence in between the gateway and the Earth. But you are right, the orbit is so much elongated that it's really scary because, they spend so much time in space with no possibility of landing on the moon. So you're right. Thank you.
Great. I think we also still have Lucas from Switzerland. Lucas, would you like to say hello to Fred?
Hello.
He's on mute. So probably. You remember Lucas?
Hi, Fredo. Hi, Dario. How are you?
Hey, hi there. I see your name.
Yeah, I'm afraid I cannot switch on the camera. I will try, but I cannot.
Okay.
Very happy that you are here. Fredo and Dario, is a great initiative. And it's always amazing to listen to you, what you did during Apollo, Fredo. And my question will be maybe during your time of Apollo, you were responsible with Ed Mitchell for the lunar module, and you went several times to Bethpage in New York to Grumman. And what is your most funny or special remember of that period?
You're talking about my time at Grumman Corporation?
Yeah, exactly.
Yeah, that was a case of they had a support cruise for each of the missions, and Ed Mitchell and I were assigned to Jim McNibbett to support that planned mission, which at the time we joined, it was Apollo 8, which later became Apollo 9 when they flip-flopped 8 and 9. And but at any rate, Jim had Ed and I in his office, and he gave us very simple marching orders. He told us, I want you to go to Grumman and make sure I have a good lunar module to fly. And that was it. That was the total tutorial. So Ed and I went to Grumman and spent most of the next year, over a year, testing lunar modules. And we really tested a little bit in LEM 1, but mostly LEM 2, which was really supposed to be the first LEM to fly in orbit, but got caught up by the Apollo 1 fire and the strict requirements on rewiring. And so they pushed it aside, and we jumped to LEM 3 to be primarily the first vehicle to fly in orbit, first test vehicle. I also did test in LEM 4 and LEM 5 while I was there. And basically, we supported just that, test operations with the buildup of procedures called OCPs, operational checkout procedures, through subsystems, through combined systems, up to a crescendo of the whole vehicle and what would be called a cell test. 61015 was an EMI test of the whole vehicle, and 6117 was a plugs in, we called it, with batteries, with ground power, and 6118 was the cell run where NASA would buy the vehicle, which involved batteries. So that was the way that was done for each of the vehicles to then be transported to Kennedy to go through a similar checkout, including a chamber test at Kennedy to get ready to be launched. I can only say it was a very difficult, long hours for everyone involved, the workers, ourselves, because we were in early part of the time there, we were really developing the test procedures. So they obviously had a lot of errors. We had anomalies that were with a tie-up for SE, support equipment, ground support equipment. So there was a lot of learning curve. Also with the workforce, because Grumman all at once had to ended up expanding their workforce over 7,000 people. Grumman had a core group that obviously were very good and experienced in testing for aircraft. They built a lot of airplanes and new airplanes, so they had a good test team, but there weren't very many that then could be stolen from the airplane programs to put into the LEM test program. So that was a lot of the learning curve too, as well as with these new people that were brought in, and now to get used to the testing, and again in a paper system way, NASA's way, which was also a little different from the company's standard. So there was all those kind of things to deal with in that early going with the early lunar module testing.
Great. So I hope everybody can see my share screen, and I would like to say that we are very honored to have you with us today, dear Fred, and we will send you this certificate as an honorary member of ASIMOF, as we did with other friends, Don Niles, with Patrizia, with Alfred and Charlie Duke when they went us. So I'm very pleased to say that we will send you this certificate as our honorary member of ASIMOF. And I would also like to say to the rest of the team that Alessandro created these drawings.
Wow.
Can you see those drawings? And Fred say that he's going to autograph those 3 drawings.
Right.
So we will do auctions just at the end of this call. So stay tuned, stay connected. We will go through these auctions, and at the end, we, with the help of Roberto, who is our member who lives in Houston, we will send these drawings to Fred so he can autograph and send it back to us. So great. Why don't we?
One thing I would ask whoever's the winner in the auction to let you can pass on what they would like inscribed on the picture. Just my name and mission, or do they want their name and something else?
Yes.
You might include that when you mail those to me to autograph.
And please, Alessandro, show up, say something, because Alessandro is great on doing all those drawings. He's an artist from ASIMOF. Alessandro, where are you?
Thank you, Dario.
Hi there.
Hi, Captain. Hi, Captain.
Hi.
Nice to meet you, and thank you to be here. You are a living legend to me, and what I have to say, I'm so excited, and thank you all.
All right. And am I muted? I can't hear anybody anymore.
Sorry, yes, I was muted. But we are going to unmute everybody and make a big applause to Fred for staying with us for over 90 minutes today. Thank you very much.
All right.
Thank you, Fred.
Thank you.
And if somebody can take a picture of this, because I'm not able to do it.
And maybe I'll see you back over here someday when Luigi comes to get another lunar rock.
Yes. Fantastic. So great. Thank you.
All right.
And we wait you in Italy, Fred.
Thank you.
All right.
And in the UK, Fred, too.
Okay.
Thank you, Mr. Hayes. Thank you from Tuscany.
All right. I see you have
Bye.
You have a disky also, yeah.
Yeah.
Yes. We are full equipped with these common modules and the other stuff. So a great thanks from everybody. And okay, if you want to be the one who will receive this autograph, we can move on to the auction now.
One thing was to hit a spot on the runway. There's actually a line painted across the runway, and I was working a little too hard with pitch control to get it on the ground to hit that spot. And as a result, I oversaturated the hydraulic system and basically locked out roll control. So only had pitch control at that point. And when I came off the runway about 900 foot long from the spot, it was rolling a little bit to the left, or the right rather, to the right. And when I made a pitch input, nothing happened. And I made a second input a little bigger and nothing happened. And I made a third input that was bigger, and now it caught up. And now I had full roll control and over control. So then I ended up with this rocking back and forth. We call a pilot induced oscillation, PIO, before Gardo smartly said, just let go of the controls a minute. And I did, and it damped out, and we landed again about another 1,000 foot down the runway. So at any rate, what they did to fix it was they now in the software assured and sort of a cascading priority of what would be fed from the hydraulics and priority between speed brakes, body flap, and the ailerons, roll and pitch. And they assured that you would always have, no matter how close to rate limiting it got, you would always have some degree of both roll and pitch control. You would never be locked out of any pitch and roll control. The others might be deferred, any commands for body flap or speed brakes, but you would always assure that the vehicle would have pitch and roll control. So that was the mod, and it was mainly made through software. What enhanced it from a piloting standpoint for the crew was we put in a HUD, a heads-up display, and that greatly it helped with the landing performance as well, for the right cues for the pilot. Because the way the orbiter was configured relative to the center pressure, center gravity, the cockpit position, you could not tell any pitch motion very well in a landing position. So where the rear end could be waggling a little bit, but you could not see that or detect that from the cockpit. Just the way the rotation was, where you were sitting in your seat and the window view you had. So again, it overcame that problem, which was kind of unique for the shuttle geometry.
Thank you. Thanks. And Fred, just one question: is the Enterprise, your orbiter shuttle, it was without the main engine, right?
Right. Yeah, it had when we flew the last two flights with the tail cone off, which made it the orbital lift to drag glider. That we had fake engines. The vehicle was ballasted though to from center gravity standpoint to where we wanted it, either forward to AFCG limits, by putting ballast in the payload bay. And so that was done through the flights. For instance, the first two flights I flew, and Joe and Dick were forward CG. We went to an full FCG for flight 3, et cetera. So we could weight ballast in the payload bay. We had a big load and two big racks of K bottles of ammonia. That was in our payload bay because that's what supplied our cooling. We couldn't open the doors and have radiators. And the little ammonia cooler they had for orbital return on entry was too small a capacity, because we flew, counting the time for 747 altitude, we flew an hour and a half, 2-hour flights. So they just put big racks of K bottles in the payload bay, and that was our primary ammonia supply for cooling.
But it was supposed to be fully equipped with the engines for a real space flight, or it was always designed just for testing?
On Enterprise, we had none of the propulsion systems. We had none of the orbital environmental systems.
Oh, okay.
We just had like an aircraft oxygen system to breathe through, mask, and a standard oxygen airplane helmet we wore in our T-38s, in fact. And so it lacked a lot of. It didn't have the other systems as well that the real spacecraft would end up having.
Yeah, so it was never redesign for a real flight, right? Where it is today, where it is located?
It is today sitting on an aircraft carrier. On the Intrepid aircraft carrier in New York City. It's in a big it's been a big enclosure, a hangar like sitting on the one end of the flight deck on that aircraft carrier.
Great.
Credo che ci sia, cioè credo che stiano dicendo pronti per partire, per cui credo che le condizioni meteo stanno migliorando, così mi stanno arrivando messaggi e forse è la volta buona. Insomma, tutto qua. Io però vi saluto perché mi sta richiamando di nuovo Rai. Ci aggiorniamo. Ciao Fred. Ciao Fred.
Hi.
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 So Paolo was saying that probably they will launch today. They got the green light for the launch.
Well, it says the fuel is being loaded, is what it says.
Yeah. Okay, Alessandro, do you want to show the disky to Fred?
Antonio. Okay. Hi, Fred. I live in Turin.
Show it.
My replica disky. Parla tu, Dario, che io l'inglese.
All right. Yeah. So everybody has a disky in Italy, it looks like.
Yes.
All right.
Now with Antonio.
Number. Yeah.
Ancora da finire, digli.
It's almost complete. We needed to complete the keyboard, but the rest is identical to the original.
All right.
Handmade with
unbelievable
3D printer.
Printer 3D, però.
Okay.
Thank you, Fred. Thank you very much.
All right.
Paolo Attivissimo, do you want to say last word to Fred?
Well, yes, I would like to take the opportunity to thank you all for arranging this wonderful gathering and for the fascinating questions. And of course, thank you, Fred Haise, for your insight into your missions, into your flights. I have one question. I'm not sure if I know the answer. It's a joke. Do you drop a 747 or do you release a shuttle?
You really drop the 747 because you're cocked up. That front stanchion is longer than the later ones they use for ferrying the vehicle. And so you're generating lift for the 747. And so when you release, the 747 loses that lift, and good for separation tends to go down while you're tending to go up. Because we worried quite a bit about that drifting back and hitting the tail on the 747. Although our loads data, we had made 3 flights where we did not separate. We had loads instrumentation on each of the 3 attach points. So with that data, we knew pretty well for the conditions we had chosen to set the release that the combined vector sum of those loads would be straight up. So we knew at least the initial impetus was going to be up and not back. So we felt pretty safe that way at the separation. Like I said, the main concern was how the flight control would operate. And could I switch quickly to the backup system if it sort of went out of control, tended to go out of control at that point. So that was the other thing to worry about and be ready to deal with.
And would you separate vertically or would you also separate sideways?
We separated vertically initially. In fact, I pre-head with the hand controller, I preset 2 degrees per second nose up pitch at the point I pushed the button. So also had a pitch rate selected, if you will, already at the point of separation. But we waited till a chase plane called clear. And when he called clear, then I would bank to the right and then get lateral separation. Yeah.
Okay. Thank you very much for clarifying that.
Right. No, that was the, in terms of worry, that first separation was much more worrisome in my mind, at least, than I ever had on Apollo 13. More from the bigger picture programmatic standpoint. Just as we were getting ready to do all of this, we had to announce a slip in the orbital schedule by, I think, almost 2 years. Was what had been announced before Columbia would make that first flight. And we had changed presidents in the country. And that's also an issue. If, in this case, Nixon had started the program, and it's kind of Nixon's program. And now Jimmy Carter, President Carter had come in. And there had never been, through the presidential election and the debates, much discussion about the space program by, frankly, either presidential candidate. So we had no idea of how President Carter would receive the shuttle program. And at the point we were in the program, there was a concern that if somehow that first flight or any flights and approach and landing tests ended up in a failure, and certainly loss of enterprise, that could possibly end the shuttle program. The president might decide right then to cancel the program. So I felt kind of a little bit of that heavy on my shoulders, that I was praying that everything went well, so we could continue on with the right support from the administration. And of course, there's always an issue in the United States of, is the president and Congress hooked up well in continuing support? Because the real money comes from the Congress. The president has a coffee fund, but the monies come from the appropriations portion of Congress. So that's the place you also got to have aligned, not just the president.
Right. Yes, you're right. So I think Fabio wanted to just ask a last question. It's up to you, Fred. When you need to leave, just.
Well, I probably ought to break. I got a daughter here that's
okay.
Got my wife lunch, but I probably ought to break here myself. Yeah.
Okay, great. So thank you very much, Fred. It was a great pleasure. A big.
All right. I was happy to see everybody, and kind of takes me out of this isolation, this stay at home. I get out about once a week, and I still wear a mask and rubber gloves.
Yes, me too.
Because this thing is still not gone, and of course I'm an older person, and as older folks have to be even more careful of not getting this virus. So I try to be very careful and certainly not bring it home too.
Great. And
yep.
You're right. Okay.
All right. Well, good.
Ciao.
Thank you very much.
Thank you, all of you. And I'll await you.
Bye.
Take well. Thanks, Fred. Thank you very much indeed.
Thank you.
Bye. I'll wait you to send the pictures. Okay.
Thank you very much, Fred. Thank you. Thank you so much.
Bye. Bye-bye.
You stay safe.
Bye-bye.
Take care. Thank you.
Thank you, guys.
Bye-bye.
I think we need all to... Let's skip the auction for today because we have the launch coming after in a few minutes. We can organize over WhatsApp or Telegram the auction for the 3 drawings over the next few days, okay? Lo possiamo fare?
Ok, sì.
Ok. Possiamo fare su...
Ottimo.
Su Telegram, dai ragazzi. È stato 2 ore con noi.
Sì,
Quando su Telegram? Lo decidiamo già o...
lo possiamo fare, non so, tanto Telegram lo leggiamo tutti, però io lo farei domani. Adesso godiamoci la partenza e il lancio serale di questa giornata incredibile. Grazie a tutti.
Grazie a voi anche.
Grazie a te, Dario.
Grazie, ciao.
Grazie a tutti.
Dario.
Grazie a te.
Buon volo.
Grazie, ciao.
Ciao,
buona serata.